Hi, this is Saka again, and tonight I thought it would be more helpful to go over some homework problems with you guys. Today in class, remember, we kind of reviewed the wave equation again, and we reviewed the wavelength and frequency and energy of the visible light spectrum. So remember, you're going to need to know the wavelength of the general ranges of colors in nanometers, and you're going to also need to what we're going to be spending time on later on is in tomorrow's lab is we're going to talk about the emission spectrum and the colors we see relate it back to electrons and all that other stuff. We touched on it a little bit today, but we'll spend some more time on it tomorrow. But I thought it would be better to wait to do the lab first before I discussed emission spectrums in more detail. And I thought tonight it would be better just to help you with some homework because we did some equations but not a whole lot of math work with it. So here we have a homework problem from tonight's homework set. So I'm cool and I will help you with your homework. And here we have a photon with this many joules of energy. So the key here is joules. So this is energy. And remember, we only have two equations right now that we're using primarily. We're using the wave equation and we're using Planck's equation. Because this is joules, we're going to start with Planck's equation. So in this case, E equals h times nu. And remember, h is a constant. H is Planck's constant, which is 6.626, 626 times 10 to the minus 34th joules times seconds. So what we're going to do here is we're going to use this equation. We already have the energy. We have Planck's constant. We're going to solve for nu. Now remember, nu is equal to frequency. So, but we want wavelength. So we're going to use Planck's equation first to solve for frequency, and then once we have frequency, we can use our other wave equation to solve for the wavelength. So does that make sense? I don't know why I'm asking. You guys can't answer anyway. So here we're going to move on here. So I'm going to go ahead and substitute in and solve. So 7.01 times 10 to the minus 19th joules equals 6.626 times 10 to the minus 34th joule seconds times nu. And so what I'm going to do here is I'm going to solve for nu. So what I'm going to do here is I'm going to divide both sides by this number here, 6.626 times 10 to the minus 34th. 6.626 times 10 to the minus 34th. And so this cancels over here. The joules cancel. And let's see, oh, this would be joule seconds also. So this cancels, and then we have joule seconds. So all that's left is 1 over second. So there's our frequency unit. And let's go ahead and divide this. So I'm going to break out my calculator just like you would need to in order to solve for this. So 7.01 times 10 to the minus 19th divided by 6.626 times 10 to the minus 34th. And when I do that, I get, so nu equals 1.0, I need to round this, so 6 times 10 to the 15th, 1 over cycles per second equals nu. So I'm not at my answer yet, but now I can use our other equation. Remember, our other equation is going to be, what was it again? It was, oh my gosh, it was, let's see, so C equals the wavelength times, times the frequency, right? And so what we're going to do here is we'll solve for frequency, sorry, not frequency, we'll use the frequency to solve for wavelength. I had a little brain fart there, I forgot what the equation was. So to solve for nu is, this is going to be equal to C over nu equals lambda. Okay, so remember C is a constant, right? And so remember that's going to be equal to 3.00 times 10 to the 8th. So here we go. This is equal to 3.00 times 10 to the 8th meters over seconds divided by 1.06 times 10 to the 15th 1 over seconds, so 1 over seconds cancels, and this equals lambda, and when we divide this out we get a number. So 3 times 10 to the 8th divided by 1.06 times 10 to the negative, not negative, positive 15th. And when we do this, we get 2.83 times 10 to the minus 7th meters. And so here's our answer for this first problem. Okay, I will be back with another problem shortly.